they are ampiarthrotic. Now look back. What does that mean? That means they move a little bit. Not much. They move just a little bit. So the syndesmosis of the fibrous joints are ampiarthrotic. Okay, suture between flat bones of skulls. And so you know all about sutures already. So they kind of look like a puzzle piece to me, how they're intertwined together. And then gomphosis, that's where a tooth fits into the jawbone. And so cone-shaped bony process and a socket in the jawbone. And you can see on the picture on the right how that tooth actually fits down into the joint. Okay, so this is your second one, cartilaginous, and they're connected by, you want to know the cartilaginous joints are connected by hyaline cartilage or fibrocartilage. So cartilaginous joints have cartilage. That's not too hard. Okay, synchondrosis, look at the word, C-H-O-N-D-R means cartilage. So you'll be able to get that one pretty easily. Together with cartilage is what that word means. Okay, synchondrosis, bands of hyaline cartilage. Some are temporary, such as, that's where bone growth is, the epiphyseal plate, if you remember. But the one you want to know, the picture here is showing you between that manubrium, that top, and the first rib, that's costal cartilage, permanent, and it would be synarthrotic. Now, think back to that slide before. What does synarthrotic mean? That means immovable. It doesn't move. The manubrium, or the manubrium, and the ribs, they don't move. Okay, symphysis is another type of cartilage joint. And think about the disc in between the vertebra, so the intervertebral disc, right? Pads of fibrocartilage, these are going to absorb shock, articular surface covered hyaline cartilage. They are ampiarthrotic. What does that word mean? Remember, that means slightly movable. And so the symphysis, you want to know that one for sure. Symphysis is where they move just a little bit. Now, when does your pelvic bones move? When does that coxal bone move? Well, it moves during childbirth, right? It has got to move then. So it doesn't move much, but it moves then. It might move a lot then, it just doesn't move very often. And then maybe when you walk, it just slightly shifts, just teeny tiny, just a limited amount of movement. So those are the cartilage joints. Okay, synovial joints, which are probably the most interesting, the ones we think of as joints. Most joints are synovial joints. So I like that. What are most joints? They're synovial. What are most joints made of? This synovial fluid. Okay. Well, what does that mean? Articular cartilage covers the end. So there is cartilage that covers the ends of the bones. I'll show you a picture in a second. The joint capsule consists of two layers, an outer fibrous layer composed of ligaments, and an inner layer with a synovial membrane and a fluid. A fluid. So synovial joints have ligaments, like, your ACL and all that. We're going to talk about some of the most important ligaments. But there's that fluid there. So synovial joints, that's the main thing you want to know, is that they have fluid. Okay, so here's just a picture, and you can see there is, look right here. Let's see, I'll do my yellow again. There's cartilage on the ends, right? I didn't do very good, did I? Okay, I'll do purple. Okay, look at the white. The cartilage on the ends, there we go. So there's cartilage on the ends of the bones, and that's called articular cartilage, where the two bones articulate. Okay, here, the whole thing right here, this whole white part, is the joint capsule. Okay, we got ligaments in there, and I don't think those are on the picture. It doesn't look like. But ligaments are what's in your joints. We hear of people tearing or pulling ligaments. Then there's the synovial membrane. That's the dark blue in the picture. The synovial cavity. The synovial fluid. Okay, so if you're looking, the light blue, joint cavity filled with synovial fluid. Okay, the meniscus, let me talk about that. Oh, darn. Let me talk about that for a second. That is extra cartilage. So some synovial joints have, and I'm going to write that in, so you write it in too. Meniscus is just additional cartilage. And we generally think about the knee. When we hear about meniscus, we think of torn meniscus, and that's the cartilage in the knee. But we actually have it in the wrist and some other areas too. Like you have it in your shoulder cavity, just a little bit sternoclavicle, where your mandible meets the occipital bone. So it's not in all joints. It's definitely in the knee, but it's just extra cartilage, and it can get torn. Okay, the bursa you definitely want to know, so highlight both of those for sure. The bursa is a fluid-filled sac, so it's kind of like an extra little water balloon for cushion, for shock absorber, for support. It's a fluid-filled sac in some joints. So all the synovial joints have synovial fluid. Some synovial joints have a meniscus, which is extra cartilage, additional cartilage, and bursa, which is a fluid-filled sac. So they all have synovial fluid, but some have bursa too. Okay, look at this picture. It kind of points it out better. You can see the meniscus there, and you can look at it, how it's wide. That's the extra cartilage. Okay, and then let's see. Yeah, there's a little bit of, that's a little bit of bursa, and so you can't really tell what it is though. That's a little better. Just like you can kind of see, it's like a water balloon. So an extra sac filled with fluid for cushion. And so some have meniscus, some have bursa. But generally, when you hear the word meniscus, you're thinking knee, right? That's where we generally refer to it. Okay. So that is, so kind of go back, think about what we've just covered. We said, from this slide, we just talked about the fibrous, the cartilaginous, and the synovial joints, right? So fibrous, cartilaginous, and synovial. That was how we classified them. The fibrous, okay, so the fibrous we said had dense connective tissue containing collagen fibers. The cartilaginous, it had hyaline cartilage or fibrocartilage. And then the synovial, that was the fluid, right? And so, and you do want to know examples of each. So fibrous cartilage, think about between the tibia and fibula. Think about sutures. That's a good one for fibrous. So on fibrous cartilage, think suture as an example. Cartilaginous joints. Think about in between the manubrium and the ribs. Think about, probably the easiest one to remember is going to be the intervertebral cartilage disc, right? And then synovial, knee, elbow, shoulder, fingers. Those are all good. I guess the knee is the best example that we talked about. Okay, so now we're going to look at functional classification. So let's turn our attention there. So slide, there we go. Okay, so slide 11. The different types, and remember that these are based off of, these are the different types of synovial. So we're still on synovial. There's, with the fluid, there's ball and socket. That's pretty easy. There's a head of a ball fits into the acetabulum of the coxal bone, right? So ball and socket. You know that one. Condyle is going to be, it says oval condyle fits into the epileptic cavity, but it's two rounded processes. Okay, plane joint, and you actually want to know, highlight, plane joint is also called gliding joint. So also called that plane gliding, same thing, plane gliding. Okay, you also want to know, think about if you wave your hand. Everybody, come on. I know you're at home by yourself. Wave your hand. That's your wrist and ankle. Examples of plane joints. Okay, the hinge joint. That's going to be, think about a door. How it opens and it goes one way. It only opens and closes. You can't move a door up and down. You can't move a door right to left. Well, some you can. But a normal door with a hinge, like a classroom door. Convex surface fits into concave. And so the hinge joint, your elbow, that's a good one to think about. your elbow only moves one way. You can't move it all the other ways. Convex surface fits into concave. But on the hinge, I want you to think that what it does is it extends and flexes. And so, do me a favor. I know you're at home by yourself, so this will be kind of weird. But go ahead and put your arms out straight. Okay, we call that extension. And then when you flex your bicep, bring your wrist up towards your elbow. Not your wrist up towards your shoulder, I guess. That would be flexing. So extend is to straighten the arm. Flex is to bend the arm. Make sure you've got that down. So extension is to straighten the arm. Extension is to straighten. Okay, flexion is to bend the arm. So when you flex your bicep, that is flexion. When you bend your arm, flexion. So you want to know those two straight. And so a hinge joint allows you to only flex and extend in one direction. So flex and extend in one direction. Make sure you got both of those definitions written in. Okay, pivot is going to be, it makes me think about when I was little and I took ballet, and you would step forward and turn and do a half turn, step forward and do the rest of the half turn. That's a pivot turn. Now that you've had your ballet lesson for the day. So you step forward, 90-degree turn, step forward, 90-degree turn, and you're back facing forward after 2 steps. So that's a pivot, but it's really a turn, right? A pivot turn. A pivot, it says a rotation. An example of that is going to be how the atlas and the axis allow you to roll your head around. So whenever you roll, and I know that's what you're probably doing right now, is rolling your head around. Okay, a saddle joint, it allows you, it's more than a hinge joint. It allows you to go in more ways. And this is like your thumb. So take your hand and put your hand out and move your thumb forward, back, up, down, forward, back, up, down. So you can move your thumb more than you can the other fingers. Okay, so types of joint movements. When we talk about muscles in the next chapter, we'll talk about the muscles have one end that moves and one end that doesn't move. Okay, so the end that doesn't move is the origin. So it is the immovable end, right? And we'll talk more about that on the next chapter. And then the one that moves is called the insertion. And so, like when you look at your bicep, the bicep is connected to the shoulder and the ulnar radius. But when you flex it, what moves? The ulnar radius in. So that would be the insertion. The shoulder attachment would be the origin. And so you want to know those two words, origin and insertion. But these are just kind of some different movements. So abduction means away from the body. Write that in. Abduction is away from the body. Oh, that's not right. Adduction means towards the body. So if you think about, you're going to fly with your arms. And then when you bring your arms away from the body and you do like a T formation, that is abduction. When you move your arms towards your body, that is adduction. And you can remember that because if you were to get abducted by aliens, you'd be taken away. Okay, flexion, extension, and that it shows the leg. So to bend the leg is flexion, straighten the leg is extension. And that's what we went over with the arm when we talked about the hinge joint. Flexion is you bending, tightening up your bicep, and then extending. And then lateral flexion would be side to side, right? Side to side. So you're going to have to write in the definitions on those because they're not there already. Okay, dorsiflexion is to flex. Plantar flexion is to what we previously considered before today to point. So plantar point. Dorsi is flexing, right? So when I was little, when I took ballet, this is your second ballet learning of the day, but we would sit in a circle at the end of class and we would do our feet. We would point and flex and point, and we had to say the words out loud as we did it. Point, flex, point, flex. Well, what we really should have said was plantar flexion, which is point, dorsiflexion, which is flex. Plantar flexion, dorsiflexion. But then we would have looked silly. Okay, circumduction or rotation, you can look in the picture, and that's just round, right? Circumduction is round, like you're lassoing. I don't know if you do that. Okay, medial rotation, medial towards the body, lateral away from the body. Okay, supination is palm up, pronation is palm down. Okay, so take your hand and put it up, palm up, and then cup it. And I wish you could see my little hand. Anyway, and so when you cup your hand like that, think about you're carrying a bowl of soup that way. So supination, palm up, pronation, palm down. Supination, so can you cup your hand and hold the soup? Supination, pronation. Okay, inversion is in toward, eversion is out. Protraction, poke your chin out. Retraction back, and then elevate, go up, like your shoulders, depression. Okay, so those are the 4 main examples of, and there's way more, but those are the main examples of synovial joints. Shoulder, elbow, hip, knee. And remember, synovial joints all have that synovial fluid, right? Okay, so looking at the shoulder joint first. So these are just some facts about the shoulder joint. And I really want you to read through this and just familiarize yourself with it, right? So the shoulder joint, you want to know it is ball and socket. Okay, the head of the humerus, and you know that already. The head of the humerus fits into the glenoid cavity. It's got a capsule. It's got ligaments. Okay, so it kind of tells you it does have some of the bursa. That's the fluid-filled sac, right? It's got a wide range of movement, but you can kind of see all of that. Now, the next slide is major ligaments in the shoulder. So pause the video and look at the look at the ligaments and look at the picture and see if you can pick those out. And like I said, I really just want you to familiarize yourself with these. So in your future, when you see these words again, you're going to think, oh, transverse humeral ligament, that's in the shoulder. Glenohumeral ligament, that's in the shoulder. So you'll know these are not the only ligaments in the shoulder. It's just 3 of them. So, and as you get into your specialty and your major, you'll have to learn more details about them. But this is just a basic information. So pause the video, look at that. And one thing hopefully you picked out, and all 3 of these, you can see the word, or kind of see humerus, right? The arm bone. So hopefully you'll be able to pick out that is the shoulder, right? So you don't have to be able to spell these or anything like that. Just maybe able to pick out which joint. Okay, next is your elbow joint. It's got 2. So the elbow, you do have to know, the elbow joint has 2. It's got a hinge plane. Whoops. And it's got a gliding plane. Okay, so a hinge is, what we really think about when we move our shoulder, when we flex our bicep. But it can also take your hand and supinate, pronate at the elbow. So the radius and ulna slide over one another. Several important ligaments. And I do want you to know that, I do want you to know the annular ligament here. But this ligament, it wraps around the head of the radius, and a lot of times it's injured in children when parents jerk up their children by the arm and you're, get in line with me. You know how all mamas do it, but some children have injured elbows if they're not finished growing and developing when their arms are jerked on excessively. But that annular ligament is a common site of injury. So take a second, just look at these, be able to pick them out. You don't have to know them real well, but you got radial, ulnar, and annular. So you can pick those out. They're elbow ligaments. Okay, the next one is a hip joint. Man, lots of people have hip problems, right? And so I really think you know all of that. Ball and socket, that's kind of obvious. Head of the fever fits into the acetabulum. The acetabulum, right, that's the cavity for the hip. Okay, major ligaments of the hip. Take a second, look at all these. Luckily, I think you'll be able to pick these out too, like the ilium bone. Let me go back here. The ilium bone, the pubic bone, and the ischial bone. I do want you to know that the iliofemoral is the strongest ligament in the body. Okay, but let's look at this hip right here. Let me go back to this one. Oftentimes, and I told you this when we did bones, but oftentimes the head of the femur will get broken off right there. And so it happens a lot of time when that bone is weak. Think about how much weight it has to hold every day for how many years, for forever, right? And so oftentimes in patients, older patients, the head of the femur will break off. And so they got to take this head of the femur right here and this head right here, and they got to put it back on there. And so they can do that with a screw and hold it in there, screw it in. Sometimes they may have to use a synthetic femur head. It depends on how bad it was broken, or if it was crushed or broken apart. But synthetic materials are used to replace joints. And that's all joints, but I did want to emphasize the hip. Steel and titanium are used. Silicone is used. But hip replacement is most common. And so I thought this was interesting. The use of materials that resemble natural body chemicals, such as coating, so they can, like articular cartilage, that can put around the steel or titanium. And now they can even do 3D printing. If you watch Grey's Anatomy, they have a 3D printer on there. I know it's pretend and inappropriate, but anyway, I like the show. Okay, so your knee joint, we know that's where the femur and the tibia, and there's the patella, all in there together. And there's your major ligaments of the knee. Man, there's a lot, isn't there? I do want to point, so you got patellar, but I do want to point one out that's pretty important. Anterior cruciate ligament. Oh, man. There we go. Anterior cruciate ligament. That's what we call the ACL. So I do want you to be able to identify that one for sure. But you'll notice that the ACL is a ligament that forms an X. So maybe write that in. Anterior cruciate ligament is a ligament that forms an X. One on the front, and then there's a posterior one on the back. So anterior and posterior. Okay, you know all these words. Sprains, tearing of connective tissue. Bursitis, inflammation of bursa. So that little balloon sac that we talked about is inflamed, it's enlarged, and you may have to get fluid drawn, right? So you've heard of people getting fluid drawn from their knee. And then, of course, arthritis is swelling or inflammation, pain in that joint. Rheumatoid arthritis, that's where your immune system actually attacks your joint. So that's a common type that is not fun, but kind of interesting, how your immune system actually attacks yourself, an autoimmune disorder. Okay, so the last slide is what happens as you get older. Well, as you get older, you die. No, just kidding. But, I mean, you really do. But as you get older, what happens to your joints? They become more stiff. More people get arthritis with age, just pain in those joints. The fibrous joints are the first ones to change. They can shorten. But the main thing is you lose the elasticity. So you're not as flexible and you're not as active, lose stiffness. And so, but activity or exercise, we know I'm a advocate of that, right? The exercise can help keep your joints functional longer. All right, well, I hope that was helpful. And I do want to say I recommend that you take time to watch this first video linked right here. It's a crash course joint video. You definitely want to do that. The way that he goes into the examples of synovial joints, like lassos and waving hands, he's pretty comical. So take a second and watch that. I think it'll help you on the test and help you understand it. So make sure you've watched that, but I hope this was helpful.